2023. It's the year we all collectively wake up to the power of artificial intelligence. Sure, AI has been shaping our world for years, perhaps just not as obvious as generative AI. But as we rush to embrace these new technologies, there is an important question we have to ask ourselves. How do we drive the technological revolution responsibly and ethically? Companies are already getting called out for scraping the internet, pulling data they probably should not be using in the first place. So what is the solution? The answer might be synthetic data. And it all begins in the city of Aalborg. Around 25% of drowning cases that happen in Denmark take place in harborfront areas. And Aalborg was no exception. People like to hang out at these bars right by the waterfront, which in connection with alcohol is a tragedy in the making. At first, the city of Aalborg installed 2 cameras to detect falls and to notify officials within seconds, and a third that would activate to track the fallen person only when the other 2 detect the potential fall. But none of that matters if the cameras cannot detect a fall. The solution is AI. It is a great idea, but it requires training data. Training an AI model to detect a fall is not an easy task. Now add another layer to this challenge: privacy. How do you train an AI model to detect these falls without exposing people's identities? The answer? Maybe thermal cameras. Because with thermal imaging, you cannot see much of facial details as you would in RGB cameras. Just heat signatures. So, how do you train this AI? The thing is, events like falling are rare, and rare events mean little or no training data. We cannot just have people randomly falling into water for training and testing the models. It has been tried. It is dangerous, not scalable, and needs annotation. The AI could tell if someone is pretending to fall, but it is not really matching how people actually fall in real life. Also, it has been tried to use dummies filled with warm water so the thermal camera could detect them falling. It's actually working, as the heat and motion signatures of the dummies are to some degree similar to those of the human. This solution is not scalable either, or comes with a lot of practical issues, and we still need annotation. Annotation simply means highlighting parts of an image or sequence of images for some machine learning algorithms so they can pick up the information that they need to focus on. Simplest form of annotation is bounding box. That means that you draw bounding boxes around objects you want to detect. How to come up with a scalable data generation method? Where do you get the data to train a machine learning model like this? This is where things get interesting. What if we simulate these real-world scenarios digitally? Let's say by using a game engine. We began training the AI models by rebuilding the entire harbor scene in game engines like Unity, Unreal Engine, adding 3D characters, recreating real-life scenarios, and layered that over the background images taken by the thermal cameras. You can generate as many samples as you need, and it comes with annotation. With this synthetic data, the model got smarter, improving the performance of the classifier used to detect falls without ever compromising anyone's privacy or endangering anyone for the data collection. Let's zoom out for a second. Let's imagine this. Cities around the world start adopting similar methods, not just for drowning prevention, for everything, from traffic accidents to health emergencies in public spaces, even improving accessibility for people with disabilities. The potential here is massive. As we move forward, synthetic data won't be just a clever workaround. It is a crucial tool. It is how we will build responsible, ethical AI. AI that actually serves us. AI that prioritizes safety, privacy, and inclusion. This is where the future is headed. And if we do this right, AI might just make our world a safer, better place. My name is Kamal, and I am Research Director here at Milestone Systems and Professor of Computer Vision and Machine Learning at Aalborg University.